you believe phytoremediation can be used in the future?
Well, that is a good question. We have hardly scratched the surface, I think, in just using our native regular plants. And again, most of the work has simply been done on plants where we've observed it to happen, not where we've purposely tried or intentionally tried to plant species with certain concentrations of contaminants or elements. So there's all sorts of work that can be done with the plants that we know about and what combinations or concentrations of these elements are able to be translocated up. Plus, we also don't know how toxic concentrations in the soil must be, or if they're too high where nothing will grow. And so sometimes we don't know to what level these contaminants can be in the soil that we can get plants to grow anyway. So there's that whole area of just trying to understand more about the plants that we know about and their either ability to grow in contaminated soils and what those high points are. And of course, the other area is that where we can breed plants that are super hyper accumulators. And so, for example, if we were to do an experiment and we planted a whole bunch of mustard plants in a variety of different soils with different levels of contamination, some of the plants would do better than others. And through plant breeding, what we would do is we would select those plants and then we would try to grow those out because they have a more propensity to accumulate plants. And so there's that ability where we could take plants that already demonstrate good abilities and then try to increase that ability by growing them out in other situations. Well, I guess I'd really like to say just a word or two about some of the work that we do with water quality. And
oh, absolutely. Absolutely. I'd love to hear it.
So when we find acid mine drainage around areas that have either been mined or had some other industrial activity which has caused the water to get contaminated, we have been building these wetlands, which are sort of natural filtering systems to remove those metals and contaminants in the water before we discharge it into streams. And so much of the work that we've done with phytoremediation has been just that, where we've tried to grow plants in ponds or in what we call wetlands, where the plants can do some of this phytoremediation. Now it's mostly not at all hyperaccumulation. The plants don't like to take iron and aluminum up in great concentrations, which are the normal pollutants. So really what the plants do in those wetland situations is that they contribute to changing the environment for the microbes. And the microorganisms in the soils and the water in these wetlands are the things that primarily do all the process work to try to degrade or bind or hold these metals so that they're not dissolved in the water. The metals actually precipitate or fall out and settle. And so in that way, the water is cleansed because these dissolved contaminants, metals, are removed from the water in the wetland system, and then they can release the water into streams. So it's an exciting bit of work that we've been working on really for nearly 30 years now, and we're getting much, much better at designing and planning the size, the types of plants, the kind of substrate or soil material. The thing that's exciting right now is we are to a point where we can now sequence the genetics and the processes that are occurring in these soils and waters, and then as a result of that, then we can be more selective of the type of genetic material that we might want to use to optimize this cleansing or decontamination process. So we are doing some really cool work right now with microbial scientists on sequencing the DNA of the organisms that are doing these processes.